Hello. For these three problems, when you're looking at them and you're looking for either the percent or a certain number with a percent above or below it, you want to use the Excel and you're using norm. So if I click here and put equals norm, there's distribution and inverse. Now, if you double click on it, it tells you what you need. So when you're using distribution, you're given an X value, the mean and the standard deviation. So you're looking for the percent. The first one, B, says find the probability that a randomly selected bag of marijuana sold on the street has a content greater than 12. So we're looking for the probability or the percent. So we put our X value, which is 12, comma, and then the mean, which was 10.7. You have it right here, mean, and your standard deviation, comma 2. And then we put comma 1 because cumulative, it's 1 under the curve, and you hit enter. Now, this value is the percent below 12. We want the percent above 12. So then you can go equals 1 minus and then click on that answer you just got, hit enter, and there's your probability. So 25.8, depending on how far they want, 4 decimal places. The 75th percentile means 75% of the data is below it. And so this time we're given a percent and we're looking for the number. So that would be equals norm, and then we want the inverse. We put our probability as a decimal. 75th percentile, 75% is below it. So 0.75, comma, the mean, 10.7, comma, the standard deviation, which was 2. And hit enter, and there's your answer. For the next one, again, you have the mean and the standard deviation already there. What is the median giraffe height? Well, if it's a normal curve, the median is the mean, and it is normally distributed. So this would just be, oh, well, let me type on it, 19. So if you have a normal distribution, your mean and median and mode are all the same value, so it's 19. What is this z-score for a giraffe? 21.5 feet tall. The z-score is x minus your mean divided by your standard deviation. So x is 21.5, so I'm going to put equals 20. Now you could do this in a calculator. Oops, put a parenthesis. 21.5 minus the mean, which was 19, parenthesis, divided by the standard deviation, which is 0.9. And so this is your z value. Find the probability that a randomly selected giraffe will be shorter than 19.5. Here they're giving us a value. We're looking for the percent. So equals norm and first one, because it gives us the x value, which was the 19.5, comma the mean, which is 19, and the standard deviation, which is 0.9. Under the curve is 1. Now this 71% is the percent below, and they wanted shorter, so it would be that answer. If they wanted greater, then you would have to take 1 minus it. E. What is the probability that a randomly selected giraffe is between the two values? So when I put in 20.3, it's giving me the percent below that. If I put 19.6, it gives me the percent below that. So if I subtract the two answers, it'll give me what's in between them. So we have to find, just like we did the 19.5, the value for 20.3, 19.6, and then subtract them. So it's equals norm. We want the distribution. Double click it. X was 20.3, comma 19 for my mean, 0.9 for my standard deviation, and 1 for cumulative. And then do the same thing, equals norm, it's the distribution one, 19.6, comma the mean, which was 19, standard deviation 0.9, 1 for cumulative, and hit enter. And then we need to subtract them. So you can go equals this one minus the last one, and hit enter. And there's your answer. F is the 85th percentile. When you're finding the 85th percentile, it means 85% of the data is below. So we do equal norm, but this time they gave us percent, so we double click on that one, put our percent as a decimal, 0.85, comma the mean, comma the standard deviation. Hit enter, and there's your answer. One last one. I'm going to delete these ones so they're okay. For this last one, this first one is the distribution of any one randomly selected item, which would be these two. Now this one's saying a sample rather than one individual. To find the sample, it is the standard deviation divided by the square root of n. So it would be equals standard deviation 2.06, comma, oops, not comma, 2.06 divided by the square root, there's square root, of your sample size, and this was 11. So this answer here would be 0.6211, round 4 decimal places, so it would be 0.6211. For a single randomly selected lunch patron, find the probability that it is between these two values. Okay, now this is single, so it's going to use the values from A for the mean and the standard deviation. So we go equals norm, and it's going to be the first one. Our X value was 7.149, comma the mean we're using the mean and standard deviation from A because it says a single randomly selected patron, comma, 2.06, comma, 1. And then we do the same thing for the lower value. And remember that because we want between, we're going to subtract them. So we go equals norm distribution. Our x value, which is 6.3984, comma, 5.58, comma, and then it's going to be the one we found here, comma, 1, and hit enter. Whoops, I must have typed something wrong. .3984, comma, 5.58, comma, 0.6211. Oh, no, we didn't. We're still using the first one. 206. Because this was still a single randomly selected one, comma, 1. There we go. So then for our answer, we need to subtract those. So equals the 0.7 minus the 0.61. Because we wanted the percent between them. For part D, you do the exact same thing, only we use the mean distribution. It's a sample size. Because it says 11 patrons, you use part B. So equals norm distribution. And then we put our mean, 7.149, comma, 5.58, comma, 6.6211. So we're using this value now because that was our standard deviation. Comma, 1, and I'm gonna, do it separate. I was gonna put it all at once, but equals norm distribution. My lower x value, 6.3984, comma, 5.58, comma, and then we're using the B again, so it's the 0.6211, comma, 1, and hit enter. Okay. .3984, 5.58. Oh, I have 2 decimal places here. There we go. I had 2 decimals typed. Now I need to subtract them. This one minus this one and hit enter. Now you could just type them in a calculator, but it's quicker here because you can just click on them. But this would be our answer. The assumption of normalcy is necessary because your sample size is below 30.